Hey guys, back at it again. It's June 5th, 2:20 p.m. Um, making a couple of moves, helping this kid, tutoring this kid, making some money off of that, and then paying for a couple of services to hopefully help me land a better job. Yeah, I mean it's pretty tough. Let's look at whoa. Okay, let's look at Glassdoor, Amazon, and Hong Kong. Let's see like how much money they are paying. What's up?
禮拜日去踩單車，佢要我買16蚊保險，跟住我要買埋俾零售，攞
Okay.
我
Okay.
嘅身份證。
Cool. How much do they pay in Hong Kong actually? Yeah, I came out per year. That doesn't sound right. Oh, I came out. That doesn't sound right either, to be honest. It was a bit low. What about like Galaxy? Oh, sorry. I don't know. That's not the main point. Main point is I just want to do this thing, right? So I'll buy these projects. I'm gonna succeed. I'm gonna win. All right, let's see. Lexicographically smallest equivalent strings. Fuck does that mean? You are given two strings of the same length, S1 and S2, and a string base string. We say S1I and S2I are equivalent characters. For example, if S1 equals A, B, C, and S2, then A equals to C, B equals to D, C equals to E. Okay? Equivalent characters follow the usual rules of any equivalence relation. Reflexivity, symmetry, transivity, transitivity, sorry, wigs. Okay. Hmm. I see. I'm thinking of using a heap, like a min heap, max heap. Um, don't exactly know if that's right, but I don't. Mm, right, because I need it in a priority order. I can use a map. I'm thinking of using a map as well. Um, so I will introduce them all into a map. Oh, what is a graph? Yeah, I'm thinking of some sort of adjacency list, right? So it's kind of a map. Uh-huh. Group each connected component of the graph and assign each node of this component. Okay, okay, okay. Relax. So the key will be a char, right? And the value will be a vector of chars. And I'll call this adjacency list. And then for character in S1, adjacency list dot I dot push back. I believe I have to do this as well, right? Because, mhm, yep, it's two-way, right? Because of symmetry. Now I have all the groups, right? Character H key will have W, character W key will have H. Sure. What is the rules for base string? Right, so U has nothing. Okay, cool. Then I would like to sort every single one of them, right? For right? So for every single one, I would like to iterator second dot sort. Don't exactly know if this makes sense, but I feel like it kind of does. Because character A in its ASCII value would have the lowest, right? And sort defaults to an ascending order, so A will be the first element after the sort. Um, and this will happen for every non-empty. If it's non-empty, then I would sort it. If it's empty, then it doesn't matter. Oh, goes next. Okay, cool. How do I test this right now? If I were to test this, what would I do? I assume there's like A, B, C, D, E, F, G, shit like that. Yeah, cool. Okay. And then for C in a string, there should be a string result, right? If C, if it's empty, then res plus or equals to C, right? And if it's not, then res plus or equals to adjacent list C first element term result. Something like that. Oops. Okay, what's going on here? I have to add itself into it too, huh? I don't even need this because there will be none that would be empty, right? Maybe like that. So what was happening? Reference binding to null pointer. Oh no. So all right, let's see. So Parker and Morris. Then in the P one, I will have P and M. In the M one, I will have M and P, right? So for P, I will find the minimum of P and M, right? And for A, I will have A and O. This should be a set, huh? I need the sorting logic. Doesn't matter. And then okay, so okay, let's trace this out. So P will have P and M, and then M will have M and P, right? Well, P and M doesn't matter, right? And then A will have A and O, and then O will have A and O. Mm-hmm. R will add R and R. This does not work. Add some extra logic so that uh, it does not exist, right? So if means there is something, I feel like there probably is a smarter way. I just couldn't think of it right now. So let's try this to see if it works. Does not count. Fine. Mhm. What, is there no find? I see. But sorting a set doesn't make sense, huh? Yeah, doesn't really make sense. Um, okay, so I guess I have to do that. So if find I on you. So you only want to push when you can't find it, right? Mm, 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 mm. All right, let's keep tracing. R will be R, and then K will be equals to K and R. This will also add K, right? And then it's E and I and E, and then R and S. R, we will add S, and then S, we will add S and R. Boom, 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 boom. Ah, see. Okay, I think there's a better way to do this. It's 26 characters, right? I got I there. So what I would do here is if Okay. Right now it's equals, right? Or if S2I is smaller than, or if that character is smaller than, uh, like that maybe? Does that work? Mhm. Okay, right. So I have I have like A equals to A, B equals to B, C equals to C, D equals to D, E equals to E, F equals to F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, W, X, Y, Z. Right? Cool. I have all these. That's my map from here. And then, and then, for every character in S1, so P, I'll check if P is smaller than M. If P is smaller than M, in which case it's not, then I'll check if M is smaller than P. If M is smaller than P, which it is, then P will become M, right? All right. And then A and M, A and O. So A, I'll check if it's smaller than O, which it is, then this will be A. And O, I'll check against A, which is not. Um, and then R and R, but it's not, right? K and R. K is smaller than R. This will be K. Well, this was still presenting a problem. So it's still the S problem, right? And then so K is smaller than R, therefore R becomes K, right? And then R is still R. And then E and I. So I becomes E. And R and S. Mm, it's connected in that sense. Uh, and you traverse through all you find the depth first, and then you find the lowest ones. I think it's something like that. Okay, cool. Um, so I think it's something like I go with DFS. Um, you go DFS. Um, while Q is empty. While Q is not empty, right? Do I want a BFS or DFS? I feel like it's something like that though. I'll check the solution. Yeah, it's a DFS, right? Yeah, so this is the part that I'm struggling with now. Um, so I knew it. I think this is still considered my own solution. So I will have it take I'll have it take an adjacency list. I will have it take um a character, right? Then we'll search. All right, let's keep going. You know what? I want some popcorn. I will finish this today. Fuck. Wow. Some popcorn from Japan, my friends. Look at that. All right, let's see. So, what's the base case here? If it's empty, you can return just an empty space. All right. Mm. All right, it's empty space.
Mhm.
Let's do that, right? Sure, whatever. And if it's not empty, then you would find the minimum. Yes? Nice. Yeah, something like that. Or maybe they should actually take that. My God. I inhaled just happened popcorn. What the fuck? It's so unhealthy, actually. I don't really know, to be honest. Right. Now I've visited this node. And if said node is empty, then I'll return C. Minimum of C and DFS adjusted list visited for every neighbor. That's insane. How am I supposed to figure that out, man? That's amazing. Oh, fuck! I was pretty close though. I got this part. I get a bit of this part. This because I don't want it to loop, right? Bro. Fuck. Bro. See, my brain is growing though. I do know it was DFS. I do know it was DFS. So grinding this definitely helps. Let's see if the submission works. Oh my God, it's such a poor answer. What the fuck? Why? Yeah, don't know what union find is. Why is this so much quicker? The fuck? What's wrong with this? Jesus. He is the goat. He is clearly the goat. Okay, well, um, don't really know what to do. All right, cool. Don't really know what this union find thing is, though. What is union find? Hmm.
So let's begin by talking about what union find does. Imagine if you had some objects and you want to group them together according to some criteria. So one such grouping might be this. Now, once you have completed the grouping, you would want to know certain properties about the groups, such as how many groups there are, and if two objects belong to the same group. The union find data structure, as its name suggests, supports two operations. The first one is called union, which takes as input two elements, x and y, from the set of objects, and it joins or unions the groups containing x and y. For example, we can start with 0 and 2 belonging to the same group, and 1 and 3 belong to the same group. And when we call this function union 0, 1, it joins or unions the groups containing 0 and 1. So the final result will be all four objects belonging to the same group. The next operation is called find, and it takes a single object x as the input and returns the group that x belongs to. So now let's see how we can implement union find. We will first walk through the ideas and discuss the code at the end. Union find is useful in graph type problems. So our first step will be to cast the grouping in the form of a graph. And the way we do that is to connect all the objects that belong to the same group with an edge, like so. Now, remember we need to find a way to determine which group each element is in. To do so, we designate a representative element for each group. This element will represent the entire group it belongs to, in the sense that the find function will always return the representative. For example, when we call find of 4, the representative of the group that 4 belongs to is 0, so therefore we return 0. And of course, the representative will return itself. As another example,
Yo.
Come on an impromptu trip with me and my bro. We booked the tickets a week prior and somehow ended up in Okinawa. Since we took the red eye flight on 2 hours of sleep, we had a fat nap as soon as we got there. And then for dinner, we hit up the spot that we randomly walked past. It looked really good, so we had some izakaya with plenty of beer. Second day, we hit the road for the aquarium, and on the way, we took the only 2 photos I have on this trip. We also bumped into the whales shark feeding town when we got there, and oh my god, it was so majestic. For dinner, we decided to go get omakase and plenty of beer again. Day 3 on my birthday, which was the only thing he planned, was to go scuba diving. It was my first time seeing sea turtles, so I was so happy. Had nothing to do after, so we drove to the beach, got an acai bowl, and he ended up hooping with the locals. For dinner, we went to a shabu shabu place and got more beer after at Family Mart, but didn't end up drinking it because we passed out as soon as we got back. On our last day, it was raining so much we had to miss our morning activities, so we went for another round of sushi, took a mini stroll after and found out our sightseeing spot is closed, Big Ritz, so we took a nap and took more sleep after. Then we find out the flight is delayed for 2 hours, so we ended up working at the airport. No itinerary trips are underrated. I love this trip so much.
Beautiful.
Okay. 嗰時
嗯
需唔需要加彈幕啊？我留咗啲空位俾你加彈幕嘅，所以頭先啲 audio 有少棘棘地嘅，因為啲0.5秒嘅 pause 已經好多啦，然後話 I'm rapping，想加彈幕啊？我需要加彈幕啊？
你覺得？
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 你會想邊啲位加彈幕啊？Yeah，你使唔使發啊？Yeah，哦，我咪 JB 咁先。
係啊，唔知啊。
點啊？我錄完個 subt 先咯，我仲要剪呢條啊點？Yeah, of course I would want someone special to do something for me on my birthday.
Yo.
The older I get, the more birthday is more about my friends still celebrating me, so I wanted to host something super cute for everyone together. This is what I had in mind. I was gonna prep everything by myself because I'm a frugal girl, but shout out to Rami. She helped me so much with the flowers and with the fruits. 其實用 wired earphone 都冇乜問題啊。Deserve all the love I receive. Nonetheless, 所以係幾 crazy 嘅，即係你聽出個分別咯。So cute and just the way I envisioned. 呢個係 earphone。所以我之前你俾咗我嗰陣，我勁開心，我完全冇問題用嗰個。Come on an impromptu trip with me. 呢個係我嘅新 speaker。Tickets a week prior and somehow ended up in Okinawa. Since we took the red eye flight on 2 hours of sleep, we had a fat nap as soon as we got there. 但唔係嘅，如果做嘢嘅話，hands free 就唔得，呢個就好好多。有陣可以放喺度啊。啊，同埋你有風嘅時候，呢個應該會好啲啊。佢有個 wind filter。Okay. I'll try to look sit with bestie with Oxon. Mike. Hello, it's me. Hi.
Sippy with bestie.
Example only call point.
Okay, so I'm initializing. A parent with
各位好，我们来解今天一课的问题啊。今天的问题是第1971题啊，它要找在图里面它是否是有路径，所谓的 when it has exists in graph。那这是一般真人就会 graph 的一个问题啊。graph 我们一般来讲，大家知道啊，基本上就是 vertex 跟 age 所形成的这样一个集合。好，那他这边特别强调它的 graph 是 birational 啊，基本上它是一个所谓无相符啊，所以它的 age 是有数的正，它顶多就是n 代表的是 n 个 vertex in 5。那我们1啊，那 n 个 vertex 呢，它一开始的话都是 disjoint。那我分别我会给它 label 啊，所以在 label 部分是在这边，是从0、1、2一直到 n-1这样 label 好。那然后呢，每一个对应的 vertex 呢，我会给它一个 rank 啊，我们这是采用 rank 的一个方式啊，当然也可以采用所谓的 size 啊。好，那
Oh my God, it's another algorithm. Okay, I am going to learn this. I am going to learn this. I'll learn it one day or another. Right now, I want to finish the lab for CS app. I have the floating ones left, and then I want to move on to assembly language because that shit's pretty interesting, to be very honest. So yeah, peace. See you tomorrow.